So first off, I'm going to go over alcohols. So just some general information about alcohols. They have the formula ROH with the OH hydroxyl group, functional group. So on the bottom, I just have a picture of a general structure of an alcohol. So the R group is usually a carbon chain attached to this OH group, which is the hydroxyl group, and that's the defining feature of alcohols. So alcohols, they're capable of intermolecular hydrogen bonding. So this leads to higher melting points and boiling points compared to normal hydrocarbons. And molecules with more than one hydroxyl group, so the diols, they'll have a greater degree of hydrogen bonding just because there's two hydroxyl groups that are able to hydrogen bond. And the hydroxyl hydrogen, so this hydrogen attached to the oxygen, is weakly acidic. So alcohols can dissociate into H plus ions and also alkoxide ions, similar to water. So they can split up into the H plus H plus proton, and then the OH minus that is usually attached to this R group carbon chain. So that's just some general information about alcohols. Next, I'm going to go into the oxidation of alcohols. So alcohols, they're the most reduced form of a carbon bonded to an oxygen. So we are able to oxidize these alcohols. And the first reagent, pyridinium chlorochromate, or mostly known as PCC, it's a mild anhydrous oxidant. So what this means is it is able to oxidize primary alcohols to aldehydes and secondary alcohols to ketones, but it is not able to hydrate aldehydes into carboxylic acids because it lacks H2O. So the anhydrous part, it means it lacks H2O, so it's unable to hydrate aldehydes into carboxylic acids, unlike the other groups, the other reagents that I'm going to go over later. So this is a pretty weak oxidizing agent, but it is able to oxidize alcohols into carbonyls. So as you can see in the picture on the bottom right, the first tertiary alcohol, after using PCC, the oxidizing agent, it is able to form a aldehyde. And then for secondary alcohols on the bottom, after using PCC, it's able to make a ketone. And just as a general rule, you can't oxidize tertiary alcohols because they're the most oxidized it can be without breaking any carbon-carbon bonds. So we can oxidize secondary and primary alcohols, but not tertiary alcohols. So just for PCC, just know that it is not as strong as the other oxidizing agents. So it is only able to oxidize into a carbonyl. So primary alcohols into aldehydes, and then secondary alcohols into ketones. But like I said, any oxidizing agent that you encounter on the MCAT that's stronger than PCC, they will be able to oxidize secondary alcohols to ketones as well. But then for primary alcohols, using a strong oxidizing agent, it will be able to produce a carboxylic acid. So just a few oxidizing agents that you might encounter on the MCAT: sodium dichromate, Na2Cr2O7, and then also potassium dichromate, K2Cr2O7, and lastly, potassium permanganate, KMnO4. So these are all strong oxidizing agents that can oxidize secondary alcohols to ketones, similar to PCC. But then for primary alcohols, instead of oxidizing it only to an aldehyde, it will oxidize the alcohol into a carboxylic acid if it's a primary alcohol. So these are strong oxidizing agents. is you can see on the bottom, it can oxidize molecules to form a carboxylic acid. So as you notice in these three oxidizing agents, one key feature is to have a lot of oxygens in them. So just as a good rule of thumb, if you see any agents with lots of alcohols in them, they'll most likely be an oxidizing agent because oxygen is a pretty electronegative element, which would want to oxidize the reagents. So that is oxidation of alcohols. And then another form of oxidation is called Jones oxidation. This is when it uses chromium trioxide as a oxidizing agent. So CrO3 is the formula for chromium trioxide. So in this reaction, the chromium trioxide is dissolved in dilute sulfuric acid in acetone, and it functions similar to those strong oxidizing agents where it oxidizes primary alcohols to carboxylic acids and then secondary alcohols to ketones as well. Let's try out this question. The oxidation of primary alcohols can produce which of the following pairs of products, depending on the reaction? Okay. Most people pick choice A, and yeah, that's the correct answer. So for this question, it asks, if you're given a primary alcohol, what products can you form depending on the reaction? So depending on the reaction, you could form different products. So if you're given a primary alcohol, if you use PCC on it, that will form an aldehyde because PCC is not a strong oxidizing agent, so it won't be able to form carboxylic acids. But any other reagents like potassium dichromate or sodium dichromate, any of those stronger oxidizing agents, they will be able to form carboxylic acid when reacted with a primary alcohol.